While the Russelectric training simulator comes with 2 touchscreens for training personnel on the automatic operation of Russelectric switchgear, the advanced training simulator comes with 3 touchscreens for training personnel on both the automatic and manual operation of the switchgear. With the addition of hardwired controls and interlock circuits, the Simulator PLC accurately mimics full manual switchgear operation, allowing personnel to train on manual switchgear operation in the comfort and safety of an office environment. For a complete understanding of the capabilities of the Russelectric Advanced Training Simulator, we recommend that you watch the Russelectric Training Simulator video first. As with the training simulator, the touchscreen monitor on the left represents the OIP, and the touchscreen monitor on the right represents the switchgear simulation. The touchscreen monitor in the middle represents the physical switchgear, displaying an overview of each switchboard. In lieu of the 3 touchscreens, a 4K ultra-high-resolution monitor is also available, displaying the Switchgear Operator Interface Panel, or OIP, the simulator controls, a switchgear elevation that mimics the front of the actual switchgear, and the manual switchgear controls. The operator can toggle between multiple switchboards using the tabs in the upper right portion of the screen. For example, this system consists of 2 load bus switchboards, load bus 1 and load bus 2, and 2 gen bus switchboards, gen bus 1 and gen bus 2. Clicking on any cubicle displays a larger detailed view of that cubicle. Note that the sawtooth pattern at the bottom of the left panel matches the pattern at the top of the right panel, indicating that the switchgear door continues from top to bottom. The alarm horn, breaker operation, and engine sounds have also been recreated to provide a realistic training experience. Now let's look at some training scenarios. An operator can simulate closing an engine to a dead bus using the simulator's switchgear evaluation screen. Clicking on the C1 cubicle zooms in on the generator controls for Gen 1. Clicking the run position on the engine selector switch signals the generator to start. After a short delay, the engine running light comes on and the generator voltmeter displays its nominal voltage. Keyed removable handles are required to operate the sync and frequency meter switches. To insert the handle, click on the keyed hole in the middle of the frequency meter switch, and then click the gen position. A master swing panel window pops up to show analog meters, which are actually located on the master controlled cubicle. Verify that the gen frequency is at 60 Hz. To insert the handle, click the keyed hole in the middle of the sync switch, and then click the on position. To ensure that only one main breaker can be closed at a time, the sync switch must be used to close any main breaker, even to a dead bus. Click the close position on the breaker control switch, then verify that the breaker closed by checking the circuit breaker status lights on the engine cubicle door. Turn off and remove the sync and frequency switch handles and move to the C2 cubicle. To manually close an engine to a live bus, place the Gen 2 engine selector switch into the run position. Insert the frequency meter switch handle and turn it to the gen position. On the master swing panel, verify that the generator main bus voltage matches the voltage on the Gen 2 meter, and that the Gen 2 frequency is 60 Hz. Turning the sync switch to the on position allows the operator to compare the oncoming generator source to the gen bus. The synchroscope on the master swing panel spins slowly, and the sync lights gradually turn on and off. The 2 sources are in sync when the synchroscope needle is at 12 o'clock and the sync lights are off. At this time, turn the breaker control switch to the closed position and verify that the breaker closes using the circuit breaker status lights on the engine cubicle door. Generators 1 and 2 are now paralleled on the generator bus. Return the engines to standby by placing their engine selector switches back to the auto position. The Advanced Training Simulator is a valuable tool for teaching operators how to respond to switchgear alarms that require operator intervention to correct. For this example, we will simulate an overcurrent trip on utility main 1. A bell alarm trip can be simulated using the breaker simulation screen. Select UM01 and then press the breaker lockout push button. The utility main breaker will open, de-energizing the load bus. Pressing the horn alarm silence push button on the master control cubicle door silences the horn. The OIP active alarm screen displays the bell alarm and alerts the operator that a load bus 1 alarm reset is required. Using the front view screens, the operator must first identify the tripped utility main breaker. A red flashing indicator light is visible in the upper left corner of the trip unit, indicating that the breaker bell alarm is active. Clicking the breaker simulates the resetting of the trip unit. Even though the bell alarm has been reset, the breaker does not automatically reclose. An additional step is required to allow the operator to be a safe distance away before the load bus is re-energized. Navigate back to the transfer control cubicle. When the operator presses the load bus alarm reset push button, the breaker recloses. The system has now been reset and all alarms have been cleared. The Russelectric Advanced Training Simulator is an invaluable tool for training personnel on both the automatic and manual operation of Russelectric switchgear. Realistic graphics help them practice and thoroughly understand the step-by-step actions required to quickly and safely address emergencies and minimize power problems. In addition, the Advanced Training Simulator can be used to formulate procedures for an almost limitless number of emergency scenarios and train operators to address such emergencies without ever putting them in harm's way. Russelectric, power control people you can rely on.